Have a look at the screen, and now we have completed this question number 5. Questions 6 and 7 I will be discussing today. Children, before I discuss question 6 and 7, I just want to first have a discussion on midpoint theorem, okay? And once I'm done with midpoint theorem, I'll come back to these questions. Does anybody wants to ask any questions or has a doubt regarding anything?
Yes, ma'am, I have doubt in the assignment.
Tell me. You have a doubt in your assignment?
Yes, ma'am.
Okay, assignment question I will discuss along with these two questions. Okay, just first let me explain midpoint here.
Okay.
Apart from assignment, anything from the exercise or from the examples of this chapter?
No, ma'am.
No? No one?
No, wait, ma'am. I had a doubt in the question we did. Question number 5.
Which?
Question number 5. The one.
Question number 5. So we have in parallelogram ABCD, 2 points P and Q are taken on diagonal BD. Okay, which part you have adopted?
The first and the third one, and the last one.
First, third, and last one. So first one is APD is congruent to CQB, right? Okay. APD is CQB. Okay. These both you have to prove congruent. How do you prove? See, it is given to you ABCD is a parallelogram. So that means, Hafsa, look carefully. This side is equals to this side. AD is equals to BC. Okay. And then can I say that this angle is equals to this angle because they alternate interior? Angle 1 is equals to angle 2. And then this angle is equals to this angle. 3 is equals to 4. Angle 3 is equals to angle 4. Right? So that is why I can use A as a congruency. No, 1 second. You cannot say 1 and 2 are equal. I've written that mistakenly. You cannot say 1 and 2 are equal, okay? Please note this. You cannot say 1 and 2 are equal. Why, children? Why can you not say 1 and 2 are not equal? Tell me. 1 and 2 are not alternate interior angle. Why? Tell me, children.
Where is angle 1?
Angle 1, I drew this, right?
Because they are not forming Z.
Yeah, they're not forming. Okay, children. Alternate interior angle form a Z, right? So this was not a Z. So mistakenly I said this. Please note this side is equals to this side. Then this angle is equals to. These were the triangles. Look, Hafsa. These are the triangles, the green colored triangles. So this angle is equals to this angle. This side is equals to this side, and this side is equals to this side, because this is given. DP is equals to BQ is given in the question. You see, DP is equals to BQ given in the question. Okay. So by SES congruence, you can prove that they are congruent, right? Tell me, Hafsa.
Yeah.
Okay. Then triangle AQB is congruent to CPD. Where do you see AQB? AQB is this triangle.
Mm-hmm.
Next is CPD. CPD is this triangle, right? Now, how can you say? First of all, this side is equals to this side. This angle is equals to this angle because alternate interior angles. And again, BQ is equals to DP is given. Again by SAS, you can say. Again by SAS, right?
Also, it's basically the same thing as the last one.
Yeah, exactly. The same thing, just different triangle. That's it. Okay.
Last one.
The last one, APCQ is a parallelogram. So APCQ is a parallelogram. Why? From the previous proof, you can say that AP is equals to CQ, and from this proof, you can say that AQ is equals to PCU. Opposite sides of a parallelogram are equal, hence it's a parallelogram. Okay? Right, children?
Yeah.
Come to, okay, now children, I'll come to midpoint theorem. Now, what does the midpoint theorem say? We'll understand step by step, very slowly I'll go. Just understand very carefully, okay? All of you just focus on the board now. So the midpoint theorem is basically telling you, let's suppose that you have a triangle, any triangle, equilateral, isosceles, scalene, any kind of triangle you can have. And what happens is, so this is a triangle that I'm taking, triangle ABC. In this triangle, children, I take two sides. So the sides I'm taking is this side and this side. These two sides I'm taking and I take their midpoint. So let's suppose E is the midpoint of AB. What does it mean that if E is the midpoint? What does it mean?
It's bisecting the line segment AB.
That means AE is equals to EB,
Yes,
right?
ma'am.
And F is the midpoint of AC. That means AF is equals to FC. This is what I have. If they are the midpoints, this is given to me. So what did I do, children? I did nothing very special. I just took a triangle. Okay, children. Let's suppose A, B, C. I took the midpoint of two sides. So this is the midpoint of the first side. This is the midpoint of the second side, and I joined them. So this becomes E, and let's call this as F. Now, children, the line obtained on joining the midpoint of two sides of any triangle. What is the line? EF is the line. That is parallel to the third side and is half in measurement of the third side. What did I say? Listen very carefully. The line obtained on joining the midpoints of two sides of a triangle is parallel to the third side and is half of that side. Okay? That means EF will be parallel to BC and EF will be half of BC. Do you understand these both points?
Yes, ma'am.
Okay.
Yes.
This is what the midpoint theorem tells you. Now, in your syllabus, you have the proof of the midpoint theorem. Okay, now how do we prove the midpoint theorem? First of all, just write this theorem. The line segment joining the midpoints of two sides of a triangle is parallel to the third side. This is first part. Okay. So what do we do is, first of all, you can do one thing. You first of all make a construction. And what is the construction? You construct. Children, see, I'll write the proof over here. This is, first of all, write the theorem. Quickly write the theorem, then I'll tell you the proof.
Done, ma'am.
Everyone has done?
Done, ma'am. Yeah, done.
Okay, children, look here. So what you will do is, first of all, proof is as follows. First of all, you have a triangle ABC. What is given? Just look at the figure very carefully. I'm referring to this figure only. Given is triangle ABC. Okay, children. And what is given? That midpoints of two sides is given already in the question. So E and F are midpoints. This is also given. E and F are midpoints. This is also given now, children. Okay, and what is the construction? The construction that you do is CD parallel to AB. So that means you're drawing this line parallel to this line. Got it? Now what you do is proof. Very easy proof, children. You have this triangle with you and you have this triangle. Okay. If I'm able to prove them congruent, then it becomes very easy for me. So what can I say? First of all, this line is parallel to this line. So I can say this angle is equals to this angle, alternate interior. So I will say angle EAF is equals to angle DCF. Okay, point number one. Why? Because they are alternate interior angles. Then I have this side is equals to this side. Why? Because F is the midpoint, right? I wrote here F is the midpoint. So AF is equals to FC. Why? Because already given in the question, right? Then next what do I have is this angle is equals to this angle. So you can write angle
Vertically up.
FE is equals to angle DFC. Why? Because they are vertically opposite angles, right? So children, I use the SAS congruency to prove that the following triangles are congruent to one another, right? Understood till here?
Yes, ma'am.
Children, now if the following triangles are congruent, so what can I say? I can very easily say, look at this statement. I can very easily say that EF is equals to DF. Where is the EF line? This line is equals to the DF line, is equals to this line. Okay? It is equals to this line. And DE, that means, let me erase. Wait. See children, I have these two triangles are congruent. I'm just marking those two triangles. So I can say first point is EF is equals to DF. That means this line is equals to this line. These both lines are equal by CPCT. Now children, BE is equals to AE is equals to DC. Now what is this? This is very important now. First of all, BE. Where is BE? This line is equals to this line is equals to the DC line is equals to this line. Now why so children? Why are these three lines equal? Again very simple. Can I say that AE is equals to DC by CPCT? I can say this line is equals to this line by CPCT. The green lines are equal, children. Can I say this or not? Like the red
Yes,
lines are
ma'am.
equal, similarly, green sides are equal by CPCT. But you see that AE was already equal to EB. It was already equal. Why? Because E was the midpoint, right?
Yes.
It was already. So actually, these three lines become equal. So what do I have? Now children, I have EB is equal to DC, right? EB is
Yes,
equals to
ma'am.
DC. Now, children, actually this becomes a parallelogram. This becomes a parallelogram. Why? Because now opposite sides are equal. Why? Because see, EB is equals to DC. Also, EB is parallel to DC. Okay, so that is why ABCD is a parallelogram. Right? ABCD is a parallelogram. If ABCD
Ma'am, it's EBC. It's EBCD because A is not a part of that.
I don't understand, Umema. What are you saying?
Ma'am, you said ABCD is a parallelogram, but here
Oh no, not
EBC.
ABCD. Yeah, this the purple one that I have marked. Okay, EBCD. Okay. So now what happens, children? If EBCD is a parallelogram, what do I get now? For a parallelogram, opposite sides are parallel. So if opposite sides are parallel, can I say that this line is parallel to this line? Can I say this?
Yes, ma'am.
Okay,
Ma'am.
I can very easily say. So you can then write thus EF is parallel to BC. So I got the first proof. I remember I told you 2 points of the midpoint theorem that the sides are parallel. So see, I got EF is parallel to BC. Now second point was it is half of BC. Now children, what happens? Look very carefully at this point. What do I have? See, I have this thing with me that EF is equals to FD. Right, children? These sides are equal to one another. Can I assume them to be x each? This is also x, this is also x. Okay. Now, children, do I have one more thing that ED is equal to BC? Why? Because it's a parallelogram. EBCD is a parallelogram, so ED is equals to BC. And you see, ED is composed of what thing now? ED is composed of what thing now? ED is composed of EF plus FD. So instead of ED, I can write EF plus FD is equals to BC. Okay. Now instead of EF and FD, I can write X plus X is equals to BC. So twice of X is equals to BC. So X is equals to half of BC. And now children, X, what was X? X, I can say EF also, I can say FD also. In my proof, I want the value to write to be EF. So I will write thus EF is equals to half of BC. Understood this?
Yes, ma'am.
Everyone tell me.
Yes, ma'am.
Raise your hands, whoever has understood. Amar, why is your camera off?
Yes, ma'am. Yes, ma'am. My camera is not working as well, I think.
Amar?
Hello.
Yes, Amar. Why is your camera off?
Yes, ma'am. There's something issue in my camera as well.
What is the issue?
It's not switching on.
Try to switch it on. Then I'll see what is the issue.
Okay, ma'am. I'll figure out.
Please try to put on your camera.
Okay, ma'am.
Put it on and tell me what is the issue.
Yes, ma'am. Put it.
What is the issue, Amar? Amar, this happens very frequently with you. Yeah, now it's on.
Yes, ma'am.
Okay, just do not put off your camera. Okay, children, you can put off your hands. Now, so the proof is easy only, right? And children, the proof is important as well, right? The proof comes in the exams. Okay, many times it has comes in the exams. So you will all practice the proof step by step. It's a very easy proof. I'll just revise it for you. What did I do? I will draw, see, what will I do is, I will first of all draw a triangle. Okay, I have midpoints of the triangle. Let's suppose this is ABC. I have the midpoints E and F. This thing was already given to me. What was my construction? My construction is I draw a line parallel to this line. So this line and this line are parallel. I have constructed. So I already know. I extended this line to a point D. Now I will prove this triangle and this triangle congruent by the SAS. Side, angle, side, angle. ASA congruency, not SES, sorry. ASA congruency I'll take, I prove them congruent. Why am I proving them congruent? To make this side and this side as equal. Okay? I got 1 point. Now my second point is, I will write this side is equals to this side is equals to this side. Okay? So why am I doing this? This makes the point that EBCD is a parallelogram. Okay? EBCD is a parallelogram you get. And if EBCD is a parallelogram, so I can very easily say BC is parallel to EF. So I got my first point. My second point will be EF plus FD is equals to ED, which is equals to BC. Just take this as X, this as X. So 2X is equals to BC and X is equals to half of BC. Right? This was only my second point. Got it? Now next is the line.
Again.
Okay. Hafsa, now which point you want me to explain again?
Probably.
Ma'am, should we write it?
Yeah, children, of course you should write it. Write it down. Hafsa, you want me to explain which point again?
I didn't understand the whole thing overall.
Hafsa, then why did you raise your hand, child? Hafsa, see, I'm going very slow. Child, you need to try to focus at least. I took 20 minutes to explain you the midpoint theorem. I can repeat. I don't have problem in that. But it's not that tough. Right? When I'm explaining you for the first time, please try to focus in the class. See, now you write down and I'll explain you again. First of all, what is given? Children, listen to me. How will you write down? First of all, you draw the figure. Draw the figure. Once you have drawn the figure, write down what is given. Write down what is the construction. And write down what you have to prove.
Okay, ma'am.
Or let's do one thing, children. Wait. I will write the entire proof again. See. You have a triangle. A, B, C is a triangle. E and F are the midpoints. This is the construction. D. Okay. Just write down given. Okay, children, of ABC. And then what is given? Only this is given. What is the construction? Write down the full spellings. Do not write short forms like me. Construction is CD just parallel to AB. To prove EF parallel BC, EF half BC. Okay. Now I'll write the proof. In triangle AEF and triangle CFD, what do I have? Angle 1 is equals to angle 2, angle 3 is equals to angle 4, AF is equals to FC. Alternate interior angles. Hafsa, now try to understand, child, and whenever you are not able to understand, just tell me at that point only. Children, go through the proof, write it in your notebooks, and tell me if you don't understand.
Okay, ma'am.
Children, just tell me when you're done, okay? I have to move ahead as well.
Done, ma'am.
Done, ma'am.
Okay, so shall I move ahead?
Ma'am, just a second.
Hafsa, did you understand now?
Yeah. Yeah, I'm done.
Okay. So look here now. Now the question says that the line drawn through the midpoint of one side of a triangle is parallel to another side and bisects the third side. Now what does this theorem tells you? That if you have a triangle, this is a triangle, and what do? You take only one midpoint. Let's suppose I am taking only E is the midpoint. Okay. And the line that is passing through this midpoint. Okay. Let's suppose you draw a line like this that is parallel to the another side. That means now E is the midpoint, and I'm telling you, I'm drawing a line passing through E such that this line is parallel to this line. Okay. Then what happens? Then automatically F is also your midpoint. F was not drawn as the midpoint. Okay, only E was given to you as the midpoint. But what am I telling you is, I am drawing a line that's passing through E and is parallel to BC. Okay, that means you take a triangle. This is the midpoint already given to you. Okay, this is ABC. And now I tell you, find the midpoint of AC. I don't know what is the midpoint of AC. You find it. So it's very easy to find the midpoint of AC. What will you do is, you will only draw a line that is parallel to this line. And you will say, ma'am, it is cutting AC at point F. So F is the midpoint. Understood the point? So this is nothing
Yes,
but
ma'am.
converse of the previous theorem. Okay, that's it. So how can you prove it? It's again a very simple proof. You can easily prove that AF is equals to FC. How? If you are able to prove this triangle is congruent to this triangle. Now children, this proof again, how can we do? Tell me, how can I prove that these both triangles are congruent?
We can take AF is equals to CF and
Uh,
vertically up.
Mema, that is what you have to prove, right, child? That is now not given to
Okay.
you.
Yes.
That is what you have to prove. You can take, okay, this angle is equals to this angle. What else can
Then
you take?
we can take vertically opposite.
Okay. If you want to take, okay, then tell me then what will be the third thing then?
AE is equals to CD.
Very good. AE is equals to CD.
And then by AAS, these two triangles are gone.
By AAS. Okay. You can say AAS, but you can do it by ASA also. How? How can you do it by ASA? Don't take the vertically opposite angle.
We can
Instead,
take the alternate interior angle.
children, can I take this angle and this angle? alternate interior.
Yes,
I can take them. Okay. Why? Because this side is parallel to this side, right? So I can take this and I will have ASA congruency only like this. So if it is congruent, so very easily AF is equals to FC. Okay. This proof you can try it as your homework. Next, we come to some questions of midpoint theorem. Okay, look at this question. ABCD is a quadrilateral in which P, Q, R, and S are midpoints of the sides AB, BC, CD, and GA. So ABCD is given as a quadrilateral. This is the quadrilateral. The red color that I'm working with. And what do they give you? They are telling you S is the midpoint of AD, P is the midpoint of AB, Q is the midpoint of BC, and R is the midpoint of RC. Okay. AC is a diagonal. This is also given to you. Now they are telling you that SR is parallel to AC. Where is SR? You have to prove this line is parallel to AC line. Very easy proof. SR is parallel to AC. How? You will say in triangle ADC, what do you have? S and R are the midpoints.
Yes, ma'am.
Okay. So what happens? SR is parallel to AC and SR is half of AC by midpoint theorem. Okay. So first point you can very easily prove. Next is PQ is equals to SR. See children, this is again very easy proof. You have to prove that PQ line is equals to SR line. Now children, by the midpoint theorem, what do I have? I have SR is equals to half of AC, point number 1. But now children, if I change my triangle, so I also have PQ is also half of AC. Second point, by the midpoint theorem. Midpoint theorem is applicable to all the triangles, right? So if it's applicable to this first triangle, then initially I'm taking triangle number 1 and I apply the midpoint theorem. Then what do? I take triangle number 2 and then again I apply the midpoint theorem. Okay?
Yes, ma'am.
Again I do this. So what do I have? I have point number 1 and point number 2. SR is also equal to half of AC. PQ is also equal to half of AC. So you can say from 1 and 2, SR is equals to PQ. Very easy proof. Right?
Yes, ma'am.
Now third is PQRS is a parallelogram. See children, now you got that SR is equal to PQ and also SR is parallel to PQ. Why? Because SR is parallel to AC. PQ is parallel to AC, so SR and PQ are also parallel. So you can write. So if in this triangle, if in this, quadrilateral, you have SR is equals to PQ and SR is parallel to PQ, thus you can say SRPQ is a parallelogram. Understood?
Yes, ma'am.
Third point. Everyone
ma'am.
understood? See children.
Yes,
So what you learn from this question, a very important lesson from this question is that if you have any quadrilateral, not just this quadrilateral, any quadrilateral, and you join the midpoints of all the sides of the quadrilateral, what do you get? You get a parallelogram. For example, I will have any quadrilateral now, children. Let's suppose I have this random quadrilateral. Okay, this is the midpoint, this is the midpoint, this is the midpoint, this is the midpoint. When I will join its midpoints, what will I get? I will get a parallelogram. It can be a square, it can be a rhombus, it can be a rectangle. Okay, it can be anything, it can be a parallelogram also, but it will be a parallelogram. Understood this?
Yes, ma'am.
Okay, so learn these small things from every question. Now next is ABCD is a rhombus. P, Q, R, and S are the midpoints of the sides AB, BC, CD, and DA respectively. So first of all, draw a rhombus ABCD. A, B, C, and D. P, Q, R, and S. So P, Q, R, S. These are the midpoints. Now they're telling you when you join the midpoints, prove that you are getting a rectangle. You are getting a rectangle. Now, children, you know one thing from the previous question. Any quadrilateral you take and you join its midpoints, you are going to get a parallelogram, right? Over here, the quadrilateral that I'm taking is a rhombus, and the parallelogram that I'm getting is a rectangle, right?
Yes,
So
ma'am.
you just have to prove that the parallelogram you get when you take your quadrilateral as a rhombus is a rectangle. That is only the question, right? So do you understand the question first? Tell me.
Yes, ma'am.
Okay. So who will tell me what is the feature of a rectangle? How can I prove that any figure is a rectangle?
All the sides are 90 degrees.
Opposite sides are equal. First of all, children, can you prove that opposite sides of this red parallelogram are equal? It is a very simple proof. Then you tell me. How can I prove that opposite sides of this parallelogram are equal?
Ma'am, the all sides are 90 degrees, so
It's not
90.
given to you, they're 90. How can you prove SP is equal to RQ and SP is parallel to RQ? Can I do a construction? Can I do a construction? So first you will
Yes,
say
ma'am.
triangle ABD. What do we have? SP parallel to DB and SP half of DB. Then in triangle CBD, what do you have? RQ parallel to DB and RQ half of DB. Second point, first point, second point. So from 1 and 2, what do you have? What do you have? SP is equal to RQ and SP is parallel to RQ. These both points I get. Now children, okay, now I know, okay, fine. That means SP RQ is a parallelogram. Can I also prove that these two are also parallel? This line is also parallel to this line and it is equal. Yes. Now I will
Yes,
just
we
do
have to do
another
the
construction.
construction.
Very good. If I do this construction, this blue line, if this diagonal I take, which triangles will I take? I will take this triangle and I will take the other triangle. Okay, children. So try this proof on your own and prove the second point on your own.
Yeah.
First of all, copy the first point and then try to do the second point. Children, did you copy this part? Please tell me, did you copy this part?
Yes, ma'am.
Okay, now
Yes,
children,
ma'am.
just stop here. Just stop here. Why? See, from here, you got 1 point, that is a parallelogram. Okay, what we can do is, see, do not write the second point. Do not try to prove PQ is parallel to SR and PQ is equals to SR. Why? We'll go by another method. What we can do is, children, after writing this point, if I am able to prove, so see, from this point, what did I get? I got that PQRS is a parallelogram, right? From this proof, from this red color proof that I've written here, we got PQRS is a parallelogram. But what do I want? I want to prove it as a rectangle. Yes, children.
Yes, ma'am.
So in a rectangle, what is it so different from the parallelogram? Just one simple thing. It has all angles as 90 degree. So how can I prove it as 90 degree? What will I do is I will draw this diagonal, okay, and take this diagonal also. Now what do I have, children? I will take this small portion. This small portion I take. In this small portion, what do I have? I have this line is parallel to this line and this line is parallel to this line. Okay. Why? Because this whole PQ was parallel to AC. So this small line, let's call this as M, Q, N, and K. Okay. So MQ is parallel to KN and NQ is parallel to KM. So the small blue one is also a parallelogram now. Tell me.
Yes, ma'am.
And now, children, what do I get? This angle plus this angle is equal to 180 degree. Tell me, is it equal to 180 degree?
Yes, ma'am. Mm.
Yeah.
Wait. Do one thing, children. Don't take this one. Take this one. Take this angle and this angle. Tell me one thing. These both angles are equal. This green angle and this green angle are equal to one another. Children, one very important thing is now diagonals of a rhombus bisect at, they bisect
90
at
degree.
90 degree. So do I have this angle as 90 degree? Do I have this angle as 90 degree? So this angle also becomes 90 degree, right? Now you prove that one angle is 90 degree of a parallelogram. That means very easy. What did I do? I'm just quickly revising. Listen very carefully. I have a rhombus. I have a rhombus with me. Okay. I took the midpoint of the rhombus. I joined them. I want to prove that when I join them, I do get a rectangle. So what will I do? I will first of all draw one diagonal and I will prove this line is parallel to this line and this line is equal to this line. Okay, so this is A, B, C, D. This is P, Q, R, S. Okay, I proved that, okay, P, Q, R, S is a parallelogram. This is I proved very easily. How? This is parallel to this and this is also equal to this. Okay, now what do I have is, children? I will draw one more diagonal of the rhombus and I will take this small quadrilateral. This small quadrilateral. And this small quadrilateral, I will say this angle and this angle are equal to one another. And first of all, you will prove that this is a parallelogram. Okay?
Okay, ma'am.
This is equal to parallelogram. Okay? First of all, you will write it. And then you will say, if it is a parallelogram, so this blue angles are equal to one another and this angle is equal to 90 degree. Thus, this angle is also 90 degree and hence this whole is a rectangle, right? Children, this chapter is a bit complex. It's a bit deep, okay, but not very difficult. If you go step by step, if you are solving all the questions very thoroughly, then it's not really so tough, right?
Yes, ma'am.
Umema's doubts could not be cleared. Umema, I'll clear your doubts in the next class. Would it be okay?